The universe is a place of infinite wonder, a sprawling cosmic theater where the laws of physics twist and bend in ways that defy logic. Imagine gazing into the endless void, only to stumble upon objects and phenomena so bizarre they seem ripped straight from the pages of science fiction. From stars that vanish without a trace to galaxies shaped like forbidden cosmic fingerprints, the cosmos is brimming with enigmas that leave even the brightest minds utterly baffled. Today, we're setting off on a journey to uncover 30 of the strangest, most mind-bending discoveries ever made in the universe, each one a puzzle that challenges everything we think we know about reality. Picture this: a planet where it rains molten glass sideways, or a black hole spinning so fast it warps the fabric of space-time into a surreal vortex. These aren't scenes from a fantasy novel, they're real, documented wonders lurking in the depths of space, waiting to be explored. For centuries, humanity has looked to the stars with a mix of awe and curiosity. But the deeper we peer into the cosmos, the more it feels like we've only scratched the surface of its secrets. Every discovery raises new questions, twisting our understanding of the universe into something stranger and more beautiful than we ever imagined. What if I told you there's a place in the universe where time itself seems to stand still, or that some stars pulse with rhythms so precise they could rival the most accurate clocks on Earth? The universe doesn't just surprise us, it humbles us, reminding us that for all our knowledge, we're still children staring into an abyss of mysteries. This video is your ticket to the front row of that cosmic spectacle, a guided tour through the most jaw-dropping, head-scratching, and outright inexplicable phenomena ever recorded. So buckle up, because by the time we're done, you'll never look at the night sky the same way again. The first stop on our cosmic tour of the bizarre takes us to a tiny, unassuming dwarf galaxy 3 billion light-years away, home to one of the universe's most stubborn puzzles. In 2012, astronomers detected a fleeting burst of radio waves so powerful it outshone entire galaxies for a fraction of a second. But the real shock came when this signal, dubbed FRB 1212, did something unprecedented. It repeated. Unlike other fast radio bursts that flash once and vanish, this one kept coming back, pulsing like a cosmic heartbeat from the void. What makes these repeating signals so baffling? For starters, they pack more energy in a millisecond than our sun produces in 80 years. Some theories point to magnetars, super dense, highly magnetic neutron stars spinning at insane speeds, their crusts cracking under immense strain like cosmic earthquakes. Others speculate about collisions between neutron stars or bizarre, theoretical objects called blitzars, black holes born from the collapse of pulsars. And yes, a few daring minds have even floated the idea of alien megastructures, though scientists quickly caution that extraordinary claims require extraordinary evidence. The galaxy hosting this enigma only deepens the mystery. It's small, faint, and brimming with star-forming chaos, a far cry from the orderly spirals we're used to. This suggests fast radio bursts might thrive in extreme environments where chaos fuels the unthinkable. Yet after years of study, no theory fully explains why FRB 1212 repeats while others don't, or how any natural process could unleash such titanic energy so rapidly. It's as if the universe handed us a riddle wrapped in a paradox, then dared us to solve it. Every time we think we're closing in on an answer, new bursts defy expectations. Some arrive in predictable patterns, others in erratic flurries, as if the cosmos is toying with us. One thing's certain, these signals are more than cosmic oddities. They're keys to understanding the universe's most violent, hidden realms. And with every pulse, they whisper a tantalizing question. What else is out there waiting to shatter our assumptions? Now, let's venture into one of the universe's most unsettling voids. A gaping abyss so vast it defies our very understanding of cosmic structure. Nestled within the constellation Bootes lies a staggering emptiness spanning 330 million light-years, a region so barren it's been dubbed the Giant Void. To put that into perspective, if you placed our Milky Way at one edge, you'd need to travel the equivalent of 33,000 Milky Ways end to end before finding even a single galaxy on the other side. This isn't just a sparse patch of space, it's a cosmic desert so extreme it shouldn't exist according to our best models of the universe. How does a void this colossal form? According to the standard cosmological playbook, matter should be distributed relatively evenly across the cosmos, with galaxies clumping into filaments and walls, leaving smaller, predictable gaps between them. But the Bootes void throws a wrench into that theory. It's not just a minor anomaly, it's a gaping hole in our cosmic map, challenging the principle known as the cosmological principle, which assumes the universe is uniform on large scales. If matter were truly evenly distributed, voids this size simply wouldn't form. Yet here it is, staring back at us like a cosmic oversight. Some scientists speculate that the void might be the result of an unfathomably ancient collision between smaller voids, merging over eons into this terrifying expanse. Others suggest it could be a scar from the universe's infancy, a relic of primordial conditions that left this pocket of space bizarrely empty. Then there's the more radical idea: what if it's not empty at all? Could this void be hiding something we can't see, like exotic dark matter woven into structures our telescopes can't detect? The unsettling truth is we don't know. Every explanation feels like grasping at cosmic straws. What makes the Bootes void especially eerie is the silence. Out there, the night sky wouldn't just be dark, it would be lonely. No neighboring galaxies, no distant stars, just an endless, crushing emptiness. For astronomers, this void isn't just a curiosity. It's a haunting reminder of how little we truly understand about the universe's architecture. If structures like this can exist, what other rule-breaking wonders are lurking in the shadows? The Bootes void doesn't just defy expectations. It dares us to rethink everything we thought we knew about the cosmos. And in that silence, the universe whispers a humbling lesson. Some mysteries refuse to be solved. From the eerie silence of cosmic voids, we turn to a star that refuses to play by the rules: KIC 8462852, better known as Tabby's star. Nestled in the constellation Cygnus, this unassuming flicker of light has become one of astronomy's most infamous puzzles, behaving like nothing else we've ever seen. Most stars dim in predictable, rhythmic patterns, but Tabby's star doesn't just dim. It plunges into darkness erratically, sometimes dropping in brightness by a staggering 22%, as if something colossal is passing in front of it. And then, just as mysteriously, it brightens again, leaving scientists scrambling for answers. At first, astronomers thought a swarm of comets might be to blame, their dusty tails blotting out the star's light. But comets couldn't explain the sheer scale of the dimming, nor its bizarre, jagged patterns. Then came the more tantalizing theory: a Dyson sphere, a hypothetical megastructure built by an advanced civilization to harvest a star's energy. The idea sent waves of excitement and skepticism through the scientific community. Could we be glimpsing the handiwork of aliens? Even the most cautious researchers admitted it was a possibility, however slim. But in science, extraordinary claims demand extraordinary evidence, and Tabby's star wasn't done surprising us. Recent observations have only deepened the enigma. The star's long-term dimming trend, where it's steadily grown fainter over years, defies all known stellar behavior. Stars don't just fade like this unless they're dying, but Tabby's star shows no other signs of decay. Some suggest it's surrounded by uneven rings of dust, while others propose interstellar debris or even a rogue planet's shattered remains. But each explanation comes with glaring holes, leaving us with more questions than answers. What makes Tabby's star so captivating isn't just the mystery, it's what it reveals about how we explore the unknown. every time we think we've pinned it down, it throws us another curveball, forcing us to question our assumptions. Whether it's comets, dust, or something far stranger, one thing's certain: this star is rewriting the rules of stellar behavior, and in doing so, it's teaching us just how much we still have to learn about the universe. Among the countless galaxies scattered across the cosmos, one stands out not for what it contains, but for what it lacks. Meet NGC 1052DF2, a galaxy that defies one of the universe's most fundamental rules. It appears to have no dark matter at all. This isn't just unusual, it's like finding a skyscraper floating in midair with no foundation. Dark matter, that invisible glue holding galaxies together, is supposed to be everywhere, making up roughly 85% of the universe's mass. Yet this ghostly galaxy spins smoothly without it, throwing decades of astrophysics into chaos. When astronomers first measured the motions of its stars, they expected to see the telltale signs of dark matter's gravitational pull. Instead, they found something shocking. The stars moved exactly as they should if only visible matter was present. No hidden mass, no unseen force, just stars behaving as if the universe's rulebook had been rewritten. The discovery sent shockwaves through the scientific community. Dark matter isn't just a minor ingredient, it's the scaffolding of cosmic structure. Without it, galaxies like ours should fly apart. Yet here's DF2, chilling in the constellation Cetus, utterly indifferent to the laws we thought were universal. How could such a galaxy exist? One camp argues it's a cosmic fluke, a rare outlier sculpted by violent interactions with neighboring galaxies, perhaps stripped of its dark matter in some ancient collision. Others propose an even wilder idea. What if dark matter isn't the only way to explain gravity? Maybe Einstein's theory needs tweaking, and DF2 is the first clue. Modified Newtonian dynamics, or MUND, suggests gravity works differently on galactic scales, eliminating the need for dark matter entirely. But MUND has its own problems, failing to explain other cosmic phenomena as neatly as dark matter does. The plot thickens when you peer at DF2's bizarre structure, a diffuse, ghostly blob of stars with almost no gas or dust, more like a cosmic jellyfish than a typical galaxy. Some researchers speculate it could be a failed galaxy, born in unusual conditions that left it starved of dark matter. Others wonder if we're just missing something, our measurements flawed by hidden complexities. What makes DF2 so thrilling is its defiance. It doesn't just challenge a single theory, it forces us to question the bedrock of modern cosmology. If one galaxy can exist without dark matter, does that mean others can too? Or is this the exception that proves the rule? Every new observation deepens the mystery, leaving us staring at the stars with a humbling realization: the universe still has a few tricks up its sleeve. And in that uncertainty lies the beauty of discovery, the chance to rewrite the textbooks, one impossible galaxy at a time. Deep in the cosmic microwave background, the faint afterglow of the Big Bang, lies a chilling anomaly that has scientists questioning the very fabric of reality. Stretching nearly 1.8 billion light-years across, the so-called cold spot is a mysterious patch of space where temperatures plummet unexpectedly, as if the universe left its refrigerator door ajar. At first glance, it might seem like a minor glitch in the cosmic data, but this frigid region defies all standard explanations, sparking debates that range from the mundane to the mind-bending. The cosmic microwave background is the oldest light we can observe, a snapshot of the universe when it was just 380,000 years old. Normally, it's remarkably uniform, with tiny temperature fluctuations that reveal the seeds of today's galaxies. But the cold spot isn't just a minor variation. It's a deep freeze that stands out like a cosmic sore thumb. One leading theory suggests it's the shadow of a supervoid, an unfathomably vast region of space with far fewer galaxies than average. As light travels through such a void, it loses energy, stretching into longer, cooler wavelengths, a phenomenon known as the integrated Sachs-Wolf effect. But here's the catch: even the largest known supervoids can't fully account for the cold spot's extreme chill. It's like blaming a snowflake for an ice age. That's where things get wild. Some theorists propose the cold spot might be evidence of a collision with another universe, a bruise left by a parallel cosmos bumping into ours during the chaotic infancy of the multiverse. Imagine two soap bubbles grazing each other in a cosmic foam, their boundaries briefly touching and leaving behind a scar. While this idea sounds like pure science fiction, it's rooted in serious physics, particularly the eternal inflation model, which suggests our universe is just one bubble in an endless, frothing multiverse. Yet not everyone's convinced. Skeptics argue the cold spot could still be a statistical fluke, a random fluctuation amplified by our limited perspective. After all, when you're mapping the entire observable universe, even a 1 in a million anomaly might pop up, but the more we study it, the stranger it gets. Recent observations reveal the cold spot isn't just cold, it's also eerily empty, with fewer galaxies than surrounding regions. This double whammy of coldness and emptiness pushes the boundaries of what we thought possible, forcing us to confront an uncomfortable truth: our best theories might be missing something fundamental. Whether it's a supervoid shadow, a multiverse collision, or something entirely unforeseen, the cold spot reminds us that the universe is far weirder than we ever imagined. It's a cosmic detective story with no clear culprit, a puzzle that challenges us to think bigger, bolder, and perhaps a little more wildly. And as we stare into that cold, enigmatic patch of sky, one question lingers: what other secrets are hidden in the afterglow of creation? Somewhere in the vast cosmic web, a monster is on the loose, a supermassive black hole, weighing as much as 20 million suns, tearing through intergalactic space at unimaginable speeds. What makes this celestial fugitive truly extraordinary isn't just its velocity. It's the dazzling trail of newborn stars stretching behind it like a cosmic breadcrumb trail, a paradox defying everything we know about these gravitational nightmares. Black holes are supposed to lurk silently in galactic centers, not go rogue, and they certainly shouldn't be creating stars. Yet here it is, a behemoth moving so fast it could travel from Earth to the Moon in just 14 minutes, leaving behind a sparkling wake of stellar chaos. The story of this runaway begins with a violent cosmic divorce. Most galaxies, including our Milky Way, have supermassive black holes anchored at their cores. But roughly 40 million light-years away, in a galaxy called RCP-28, something went catastrophically wrong. Astronomers suspect a galactic collision, a brutal tango between two galaxies that sent their central black holes spinning toward each other. As they spiraled closer, they unleashed gravitational waves, rippling the fabric of space-time itself. When they finally merged, the energy kick was so powerful, it ejected the newly formed black hole like a cosmic slingshot, hurling it into the void at over 4 million miles per hour. But the real shock came when telescopes spotted a narrow corridor of young, blue stars tracing its path, stars that shouldn't exist. Black holes are notorious for destroying matter, not fostering it. The leading theory: as the black hole plowed through intergalactic gas clouds, its immense gravity compressed the material, triggering star formation in its wake. It's like a runaway train laying down new tracks as it speeds away, turning destruction into creation. The stars in its trail are hotter, younger, and more densely packed than those in typical galaxies, a glittering testament to the black hole's unsettling influence. The aftermath is just as mind-bending. Back in its home galaxy, the black hole's violent exit left behind a disrupted core, a galactic wound still healing. Meanwhile, the fugitive shows no signs of stopping, destined to drift forever in the darkness between galaxies. Its discovery forces us to rethink how black holes shape their environments, proving they're not just destroyers but accidental architects of cosmic change. And as we watch this gravitational outlaw streak across the cosmos, one question lingers: how many other rogue black holes are out there, rewriting the rules of the universe in their wake? Picture hundreds of galaxy clusters, each containing thousands of galaxies, streaming through the cosmos like leaves caught in an invisible river, all hurtling toward something we can't see, something beyond the edge of our observable universe. This isn't science fiction, it's the mysterious phenomenon known as dark flow, a discovery so unsettling it threatens to upend our understanding of the universe's origins. When astronomers first noticed this collective motion in 2008, it sent shockwaves through the scientific community. These clusters weren't just drifting randomly, they were being pulled with eerie synchrony toward a point in the distant void, as if the cosmos itself had a hidden current. To grasp just how bizarre this is, consider the Big Bang Theory's foundational principle. The universe should expand uniformly, with matter distributed evenly enough that no single direction holds special sway. Yet dark flow defies that expectation, revealing a preferred direction of motion on a scale so vast, it hints at forces operating beyond the boundaries of our observable cosmos. The sheer power required to tug entire galaxy clusters suggests something colossal lurks out there, perhaps a structure so massive it warps space-time itself. But here's the problem: according to our current models, nothing that big should exist outside our cosmic horizon. The observable universe is all we can see, all we can interact with. So what's pulling these galaxies? The leading theories range from the mind-bending to the downright heretical. One possibility is that the dark flow is evidence of a neighboring universe, a separate bubble of reality brushing against ours and exerting gravitational influence. In the multiverse scenario, our cosmos isn't alone. It's one of countless others, each with its own physical laws. If one of these universes happened to collide or graze ours in the distant past, it could have left behind a gravitational imprint, a cosmic wake dragging galaxies toward it. Skeptics, however, argue the data might be flawed, a trick of incomplete measurements or systemic errors in interpreting cosmic microwave background radiation. But the more we study it, the harder dark flow is to dismiss. Recent observations suggest it extends even farther than initially thought, with galaxy clusters over 3 billion light-years away, all aligning in the same inexplicable motion. It's as if the universe is whispering a secret we're not equipped to hear. If dark flow is real, it means our cosmic neighborhood is just a small part of something far grander and far stranger. The Big Bang might not have been the solitary event we imagine, but one ripple in a much larger, more mysterious fabric of existence. What makes dark flow so thrilling isn't just the mystery, it's the humility it forces upon us. For all our telescopes and theories, we're still peering through a keyhole, catching glimpses of a reality we can't yet comprehend. Whether it's proof of parallel universes, unknown physics, or something beyond our wildest speculation, one thing's certain: the universe still has secrets it's not ready to give up. And in that uncertainty lies the most exhilarating possibility of all: the chance to rewrite the story of everything. Rising from the heart of our Milky Way like twin cosmic geysers, the Fermi bubbles stretch 50,000 light-years into space, one above the galactic plane, one below, glowing with an eerie haze of gamma rays. These colossal structures, discovered in 2010 by the Fermi Gamma Ray Space Telescope, are anything but subtle. Imagine two towering orbs of high-energy radiation, each large enough to engulf half our galaxy, yet invisible to the naked eye. Their discovery upended our understanding of the Milky Way's quiet core, revealing a violent past we never knew existed, the question haunting scientists. What could possibly unleash such staggering energy? Two leading theories vie for dominance, each more dramatic than the last. The first points to our galaxy's supermassive black hole, Sagittarius A star, as the culprit. 6 million times the mass of our Sun, this sleeping giant might not be so dormant after all. roughly 4 million years ago, it could have gorged on an enormous feast of gas and stars, belching out jets of radiation and charged particles in a cataclysmic tantrum. The Fermi bubbles, then, would be the fossilized remnants of that ancient eruption, a cosmic belch frozen in time. Supporting this idea are the bubble's edges, sharp and well-defined, suggesting a single, explosive event rather than a slow leak. But there's a wilder possibility: dark matter annihilation. If dark matter particles, those elusive, invisible bits of the universe's hidden scaffolding, collide and destroy each other near the galactic center, they could release a torrent of gamma rays. The bubble's symmetrical structure and energy signatures align eerily with some dark matter models, as if we're glimpsing the aftermath of an invisible war waged in the heart of our galaxy. Skeptics counter that known astrophysical processes like black hole outbursts can explain the bubbles without invoking exotic physics, yet the dark matter hypothesis lingers, tantalizingly unresolved. Adding to the intrigue are the bubble's microwave haze, a fog of high-energy electrons swirling within them, and their peculiar X-ray chimneys, narrow conduits of hot gas linking the bubbles to the galactic center. These features suggest the story isn't as simple as a one-time explosion. Perhaps the bubbles formed through multiple eruptions, or maybe they're still being fed by ongoing activity from Sagittarius, a star. What makes the Fermi bubbles so thrilling isn't just their scale. It's the reminder that our galaxy has a tempestuous side. We think of the Milky Way as a serene spiral, but these bubbles reveal it's capable of violence on a scale we're only beginning to fathom. Whether relics of a black hole's feast or echoes of dark matter's secrets, one thing's clear: our cosmic backyard holds mysteries written in gamma rays waiting to be decoded. And with every new observation, we're one step closer to reading the story they tell. Deep beneath the ice of Antarctica, a balloon-borne experiment named Anita. The Antarctic Impulsive Transient Antenna has been catching cosmic whispers that shouldn't exist. Designed to detect high-energy neutrinos from space, Anita made headlines when it picked up something far stranger: particles blasting upward from Earth's surface, as if the planet itself were firing cosmic bullets into the sky. These events defy every known law of particle physics, hinting at either a revolutionary discovery or a crack in the very foundation of our understanding of reality. Neutrinos, often called ghost particles, are infamous for their ability to pass through matter undisturbed. Trillions stream through your body every second, leaving no trace. But high-energy neutrinos are different. When they collide with atoms in ice or rock, they create detectable radio waves, which is exactly what Anita was built to find. The catch: those signals should come from above, as cosmic neutrinos rain down from space. Instead, Anita spotted pulses emerging from below, suggesting neutrinos had traveled straight through thousands of miles of solid Earth before erupting upward. That's impossible unless our particles have a secret. Theorists scrambled for explanations. One tantalizing possibility involves sterile neutrinos, hypothetical particles that interact only via gravity, slipping through matter like ghosts through walls. If these exist, they might oscillate into regular neutrinos mid-journey, creating the illusion of particles tunneling through the planet. Another idea is even bolder. What if these detections are evidence of supersymmetry, a theory predicting exotic partner particles for every known particle in the Standard Model? Such a discovery could rewrite physics overnight, yet for all the excitement, skepticism lingers. Could these signals be flukes, glitches in the detector, or misread cosmic rays? Subsequent experiments like IceCube haven't replicated the anomalies, leaving Anita findings in limbo. But the mystery persists because if even one event is real, it points to physics beyond our wildest theories. Imagine a hidden world of particles dancing just outside our perception, occasionally flickering into view like shadows on a cave wall. Anita anomalies remind us that the universe loves a good paradox. Whether they reveal sterile neutrinos, cracks in the Standard Model, or something entirely unforeseen, These upward-firing ghosts challenge us to think bigger. After all, the greatest discoveries often begin with a single, impossible signal, a cosmic wink urging us to look closer. And in that uncertainty lies the thrill of the hunt, the chance to glimpse the universe's best-kept secrets. The James Webb Space Telescope was supposed to clarify our cosmic story, but instead it's thrown the universe's baby photos into chaos, staring deeper into space and further back in time than any instrument before it. JWST uncovered galaxies so massive, so mature, they shouldn't exist. These cosmic toddlers, spotted thriving just 200 million years after the Big Bang, are the equivalent of finding a skyscraper in the Stone Age. Their sheer size and complexity defy every prediction about how quickly the early universe could build such structures, leaving astronomers with a haunting question: did we get the universe's timeline completely wrong? One of the most jarring examples is Macy's galaxy, a fully formed cosmic city gleaming when the universe was a mere 380 million years old, far too young to host something so polished. According to conventional models, galaxies this size need billions of years of gradual mergers and gas accumulation to grow. Yet here's Macy, flaunting mature stars and intricate spiral-like features, as if cosmic evolution hit fast forward. The discovery wasn't a fluke. JWST infrared eyes have since spotted dozens of these universe breakers, galaxies up to 100 times more massive than simulations predicted for their era, some even housing supermassive black holes far sooner than physics allows. The implications are staggering. If these galaxies are real and not some observational illusion, they could upend the standard model of cosmology. One radical theory suggests dark matter in the early universe clumped faster than we thought, turbocharging galaxy formation. Others propose tweaks to Einstein's gravity or even wilder ideas, like a mirror universe bleeding matter into ours during the Big Bang. Even the speed of light's constancy has been questioned. Could fundamental constants have changed over time? Skeptics, meanwhile, argue the galaxies might simply be closer than they appear, their light redshifted by unknown phenomena. But JWST painstaking spectroscopy keeps confirming their impossible distances. The most unsettling possibility: we've misjudged the Big Bang itself. What if the universe isn't 13.8 billion years old, but far older, with a hidden epoch of expansion we've yet to uncover? Or could these galaxies be remnants of a previous cosmic cycle, survivors of a universe that existed before ours? Every answer leads to deeper questions, revealing how little we truly grasp about the universe's first whispers. JWST discoveries aren't just rewriting textbooks, they're tearing them apart, forcing us to confront the humbling truth that the cosmos might play by rules we haven't even imagined yet. And in that uncertainty lies the thrill of discovery, the chance to witness science reinvent itself in real time. Imagine a galaxy shaped like a cosmic gemstone, its brilliant ring studded not with diamonds but with black holes. This is AM06444741, a celestial oddity also known as the Ring Galaxy, where an ancient collision forged one of the universe's most mesmerizing spectacles. Stretching 150,000 light-years across, this galaxy resembles a ripple frozen in time, its sapphire blue ring shimmering with young stars. But peer closer, and the ring reveals a darker secret. It's dotted with ultra-luminous X-ray sources, each one a black hole or neutron star feasting on trapped stellar material, cosmic pearls strung along a gravitational necklace. The story of this eerie ring begins with a galactic hit and run. Roughly 300 million years ago, AM06444741 was a normal spiral galaxy, minding its own business until a smaller intruder smashed straight through its core. Like a rock hurled into a pond, the collision sent shockwaves of gas and dust rippling outward, compressing material into a dense, star-forming wave at the edges. But as the ring of newborn stars blazed to life, another phenomenon took hold. supermassive black holes, once anchored at the galaxy's core, were dragged along the expanding ring like crumbs caught in a whirlpool. Today, these black holes, some weighing dozens of times our sun's mass, glow fiercely as they devour trapped gas and companion stars, their X-ray screams betraying their presence. What makes this pearls on a string formation so extraordinary is its defiance of expectations. Black holes of this size typically lurk in galactic centers, not scattered along a cosmic carousel. Yet here they are, strung like macabre ornaments, their existence a testament to the chaos of galactic collisions. Some scientists argue the ring's dense environment fuels their survival, providing endless fodder for their insatiable appetites. Others speculate these black holes might be newborn from the collapse of massive stars within the ring itself, a byproduct of the collision star-making frenzy. The ring galaxy's beauty hides a violent irony. It's both a cradle and a graveyard. While its blue glow celebrates newborn stars, the black holes among them are busy devouring their neighbors, a reminder that creation and destruction in the cosmos are often two sides of the same coin. For astronomers, AM 06444741 is more than a curiosity, it's a living laboratory, showing how the universe repurposes chaos into hauntingly perfect patterns. And as we stare at this black hole-studded ring, we're left wondering, how many other celestial collisions are out there weaving their own strange tapestries in the dark? In 2020, scientists peering into Earth's upper atmosphere stumbled upon something straight out of a sci-fi thriller, a 600-mile-wide vortex of plasma swirling menacingly over the North Pole like a cosmic tornado. This wasn't just another aurora or solar flare, it was a full-blown space hurricane, complete with rotating arms of electrified gas and an eerily calm eye at its center. For 8 hours, this monstrous structure raged 400 miles above the Arctic, raining electrons instead of water, rewriting our understanding of space weather in real time. What makes this phenomenon so unsettling is how closely it mirrors hurricanes on Earth. Only instead of warm ocean water fueling its spin, this storm fed off a chaotic marriage of solar wind and Earth's magnetic field. Normally, the solar wind, a stream of charged particles from the sun, flows smoothly around our planet's magnetic shield, but during this event, something went haywire. The solar wind's magnetic orientation flipped, tangling with Earth's field lines like crossed wires, creating a perfect storm of instability. The result: a spiraling mass of plasma that siphoned energy from near space into the upper atmosphere, unleashing a downpour of charged particles normally seen only during intense geomagnetic storms. The hurricane's discovery solved a slew of auroral mysteries. For years, pilots and astronauts had reported bizarre, spiral-shaped auroras that defied explanation. Now we know these were likely the fingerprints of space hurricanes, twisting the northern lights into strange new patterns, but the implications go far beyond pretty lights. Such storms could scramble satellite navigation, disrupt radio communications, and even knock out power grids, a reminder that space weather isn't just a distant curiosity but a tangible threat. Perhaps the most chilling revelation is how long we've missed them. Unlike terrestrial hurricanes, space hurricanes are invisible to the naked eye, detectable only through specialized radar and satellites. That means they've likely been raging overhead for centuries, hidden in plain sight. With solar activity ramping up toward its next peak, the question isn't if another space hurricane will form, but when and how powerful it might be. This discovery tears down the artificial divide between Earth and space weather, proving that the cosmos doesn't just influence our planet from afar, it can brew storms in our own backyard. And as we stare up at the seemingly calm night sky, one truth becomes clear: the universe is far more dynamic and far stranger than we ever imagined. At the heart of our cosmic neighborhood, an invisible force tugs at the Milky Way with relentless power, dragging our galaxy and everything around it toward an unseen destination at a staggering 14 million miles per hour. This enigmatic phenomenon, known as the Great Attractor, isn't just a curiosity, it's a gravitational bulldozer reshaping our corner of the universe. And yet, for decades, its secrets remained hidden behind one of the cosmos' most frustrating blind spots, the zone of avoidance. The mystery begins with the simple fact that everything in our galactic neighborhood is moving together, not just drifting aimlessly, but flowing like a cosmic river toward some distant, massive concentration of matter. Early observations revealed this peculiar motion in the 1970s, but pinpointing its source proved nearly impossible. Why? Because the Great Attractor lies directly behind the plane of our own Milky Way, obscured by thick clouds of dust, gas, and countless stars, a region astronomers call the zone of avoidance. It's like trying to study a lighthouse while standing in front of a floodlight. The brilliance of our own galaxy blinds us to what lies beyond. Even with these obstacles, scientists have pieced together clues about the attractor's identity. What they've found is both underwhelming and perplexing. A vast supercluster of galaxies called the Norma Cluster, sitting roughly 250 million light-years away. On paper, this cluster is massive, but not nearly massive enough to explain the sheer gravitational pull we're experiencing. That means the Norma Cluster is likely just the tip of the iceberg, a visible part of something far grander lurking in the shadows. Some researchers speculate the Great Attractor might be part of an even larger structure, like the Laniakea supercluster, a web of galaxies spanning 500 million light-years with our Milky Way clinging to its outer fringe. But unraveling the attractor's true nature requires peering through the zone of avoidance, a challenge that's pushed astronomers to get creative. Infrared and radio telescopes, which can penetrate dust clouds, have revealed glimpses of hidden galaxies behind the Milky Way's glare. Each new observation adds another piece to the puzzle, suggesting the Great Attractor might not be a single thing at all, but a dense knot in the cosmic web where multiple filamentary structures converge, their combined gravity orchestrating the motion of thousands of galaxies. What makes this mystery so thrilling isn't just the scientific detective work. It's the realization that we're caught in a celestial tug of war, hurtling toward an unseen destination we're still struggling to map. The Great Attractor forces us to confront how little we know about the universe's large-scale structure, and it humbles us with a simple truth: sometimes the most powerful forces are the ones we can't even see. In the cosmic menagerie of strange celestial objects, few are as visually striking or as scientifically baffling as the Blue Ring Nebula. Discovered in 2004, this eerie, ultraviolet halo surrounding the star TYC 259777351 looks like a glowing sapphire thrown into the void. But its beauty hides a violent origin story. This bizarre structure might be the ghostly aftermath of two stars colliding in a stellar merger so rare we've never seen anything like it before. What makes this nebula so puzzling isn't just its vivid color. It's the peculiar way that light interacts with it. Most nebulas glow because they're either reflecting starlight or emitting their own radiation, but the Blue Ring Nebula does something weirder. Its ultraviolet signature comes from excited molecular hydrogen, a fingerprint that suggests the nebula is actually a hollow, cone-shaped shell of debris expanding outward from the central star. Imagine a cosmic balloon inflating unevenly, with one side tilted toward us, creating the illusion of a perfect ring. The leading theory behind this cosmic jewel is as dramatic as it gets. Astronomers suspect that a few thousand years ago, this wasn't a single star at all, but a binary system, two stars locked in a gravitational embrace. Over time, the larger star began to swell, eventually engulfing its smaller companion. The resulting chaos would have been apocalyptic, the smaller star spiraling inward, tearing through the outer layers of its partner, and finally merging in a cataclysmic explosion of energy. The force of that merger would have ejected massive amounts of material into space, forming the intricate shell we see today. But the real smoking gun lies in the nebula's chemistry. Spectrographic analysis reveals bizarre traces of ionized metals like magnesium and iron elements you'd expect to find deep inside a star, not floating freely in space. This suggests the collision was so violent, it dredged up material from the star's cores, scattering their guts across the cosmos. Even stranger, the central star shows signs of rapid rotation, spinning faster than it should for its age, another telltale clue of a recent merger. The Blue Ring Nebula is more than just a cosmic oddity, it's a time capsule. Stellar mergers are thought to be rare, short-lived events, and catching one in this transitional phase is like stumbling upon a crime scene mid-action. By studying its structure and composition, astronomers hope to unlock secrets about how stars evolve, how binary systems meet their ends, and even how heavy elements spread through the galaxy. And as we peer deeper into that sapphire glow, one thing becomes clear. The universe has a flair for drama, turning destruction into some of its most breathtaking art. Drifting alone through the interstellar void, untethered to any star, a rogue planet named SIMP J0136566 + 0933473 defies everything we thought we knew about planetary behavior. This cosmic wanderer, discovered just 20 light-years away, isn't just a cold, dead world, it's a powerhouse, boasting a magnetic field 200 times stronger than Earth's, crackling with energy so intense, it creates shimmering auroras without the need for a parent star. Auroras on Earth, like the northern lights, are the result of solar wind particles colliding with our magnetic field, funneled toward the poles in a dazzling light show. But SIMP auroras are something else entirely, a solitary spectacle with no star to fuel them. So how does this orphaned world pull it off? The answer lies in its turbulent interior. Unlike Earth, where our magnetic field is generated by a churning metallic core, SIMP magnetic fury likely comes from its very nature, a failed star or brown dwarf, too massive to be a planet but not hefty enough to ignite nuclear fusion. Trapped in limbo between star and planet, it simmers with leftover heat from its formation, driving violent convection currents in its electrically conductive atmosphere. These swirling currents act like a cosmic dynamo, generating a magnetic field of monstrous strength, one that whips charged particles into frenzied motion, creating auroras that dance in the darkness entirely on their own. But SIMP mysteries don't stop there. This rogue world is also blisteringly hot for something without a star, with surface temperatures soaring to over 800 degrees Celsius. That heat isn't just residual, it's actively maintained by the planet's magnetic turmoil, which traps and accelerates particles in a relentless feedback loop. Imagine Jupiter's auroras on steroids, amplified by a magnetic field so intense, it could strip the data from a credit card at 1,000 miles away. The discovery of SIMP forces us to rethink what makes a planet alive. Traditionally, we've assumed that worlds without stars are frozen wastelands, destined to fade into the cold. But this cosmic nomad proves otherwise, a vibrant, dynamic place where magnetic fields replace sunlight, and auroras blaze without a sun to spark them. It's a reminder that the universe doesn't play by our expectations. Out there in the darkness, untethered and unseen, there might be countless other rogue worlds crackling with hidden energy, rewriting the rules of what it means to be a planet. And with every new discovery, we're reminded, isolation doesn't mean stillness. Sometimes it's in the deepest voids that the cosmos shines brightest. Amid the swirling chaos of the cosmos, one structure stands out with unnerving precision. The Red Rectangle Nebula, a cosmic masterpiece so geometrically perfect, it looks as though it was drafted by an otherworldly architect. Glowing with an eerie crimson hue, this nebula stretches across space in a crisp X shape, its stark symmetry defying the usual organic, cloud-like forms of its celestial cousins. At its heart lies HD 44179, a dying star locked in a gravitational dance with its binary companion, a partnership that may hold the key to this nebula's razor-sharp angles. The secret to the red rectangle's symmetry lies in the violent ballet of its central stars. As the primary star nears the end of its life, shedding layers of gas and dust in a series of convulsive eruptions, its companion star funnels this ejected material into two opposing cones. Picture a spinning top wobbling wildly, its axis tracing a double cone in space, except here, the cones are sculpted by gravity, their edges sharpened by the binary system's precise orbital mechanics. Over time, these cones intersect, creating the nebula's unmistakable X-shape, a frozen snapshot of celestial geometry in action. But the mystery deepens when you examine the nebula's eerie glow. Unlike most nebulas which shimmer with the diffuse light of ionized gases, the red rectangle's light is unusually concentrated, almost crystalline. The reason? A bizarre form of carbon-based dust, its molecules arranged in a way that scatters light with uncanny efficiency. These tiny grains, forged in the outer layers of the dying star, are no ordinary soot. They're thought to be polycyclic aromatic hydrocarbons, complex organic compounds that fluoresce under starlight like cosmic neon signs. Some scientists even speculate these molecules could be precursors to life's building blocks, hinting that the chaos of dying stars might seed the universe with the ingredients for biology. The nebula's vivid red color adds another layer of intrigue. Unlike the fiery hues of emission nebulas which come from excited hydrogen, the red rectangle's crimson glow arises from a process called Raman scattering, where light bounces off molecules in a way that shifts its wavelength. The result is a color so distinctive, it's become a reference point for studying similar structures elsewhere in the galaxy. What makes the red rectangle truly captivating isn't just its beauty, it's the way it bridges art and physics. Here, the universe doesn't just create chaos, it engineers perfection, turning stellar death into a masterpiece of symmetry. And as we unravel its secrets, we're left with a humbling thought. If something this precise can emerge from cosmic turbulence, what other hidden order might the universe be hiding in plain sight? Among the countless celestial oddities scattered across the cosmos, few challenge our fundamental assumptions as boldly as the triple quasar system QQQ-J1519 plus 0627. These three blazing beacons of light, bound together by gravity yet separated by staggering distances, shouldn't exist according to everything we know about the universe's structure. Quasars, the luminous cores of distant galaxies powered by voracious supermassive black holes, are already rare enough, with astronomers spotting only about 100,000 across the observable universe. The odds of finding three in a single gravitationally linked group, statistically, it's like finding three needles in a haystack the size of a galaxy cluster. What makes this trio so perplexing isn't just their unlikely proximity, it's the scale at which they're operating. The quasars are separated by about 30,000 light-years, distances that would comfortably fit within the Milky Way's boundaries. But here's the catch: quasars are supposed to be loners, separated by billions of light-years in a universe that's meant to be uniform on large scales. The cosmological principle, one of astronomy's bedrock ideas, states that matter should be evenly distributed when viewed at grand enough scales. Yet these three cosmic monsters huddle together like conspirators, flouting the rules in plain sight. One explanation points to an unthinkably massive galaxy cluster acting as a gravitational lens, warping space-time to create the illusion of closeness. But meticulous observations have ruled that out the quasars are truly neighbors, not a trick of light. Another theory suggests they're the remnants of an ancient galactic pileup, where three gas-rich galaxies collided, funneling material into their central black holes and igniting quasars simultaneously. The problem, even in dense galactic environments, such synchronized feeding is absurdly improbable. It'd be like three volcanoes erupting in perfect unison after a single earthquake. The implications ripple far beyond this oddball trio. If structures like this can form, the cosmological principle might need revising, or at least it's not as universal as we thought. Some theorists argue the universe could be lumpier on certain scales, with matter clustering in ways our models don't predict. Others wonder if we're seeing a rare snapshot of a fleeting cosmic phase, like catching 3 lightning strikes in the same spot. Whatever the case, the triple quasar stands as a glaring exception, a cosmic eyebrow raised at our assumptions. Perhaps the most unsettling thought is how many other rule breakers we've missed. If something this improbable slipped through the cracks, what else is lurking out there, waiting to append another fundamental truth? The universe doesn't just defy expectations, it delights in doing so, leaving us to pick up the pieces of our shattered assumptions. And with each discovery, we're reminded the cosmos writes its own rules and we're just struggling to read them. Deep in the constellation Sagittarius, a cosmic predator lurks, a pulsar spinning so fast it's literally tearing its companion star apart. Meet PSRB 1957+20, better known as the Black Widow pulsar, a celestial horror show where a super-dense stellar corpse whips around at a mind-blowing 622 revolutions per second, blasting its unfortunate neighbor with enough radiation to evaporate it into space. This isn't just a star system, it's a slow-motion massacre playing out over millions of years with the pulsar as both executioner and beneficiary, feeding on the very star it's destroying. Pulsars are already among the universe's most extreme objects, neutron stars left behind after supernova, packing more mass than our sun into a sphere barely the size of a city. But the Black Widow takes things to another level. Its millisecond spin generates a magnetic field of unimaginable strength, firing twin beams of gamma rays and X-rays from its poles like a lighthouse gone berserk. These beams sweep across space with such precision they could rival atomic clocks, but they're not the real nightmare. The true terror lies in the pulsar's spider legs, vast tendrils of high-energy particles stretching outward, wrapping around its companion star like a predator ensnaring prey. That companion, a once ordinary star, is now a ghost of its former self. The pulsar's relentless radiation has cooked it from the outside, stripping away layers of gas at a rate of 1 Earth mass every million years. The star's outer atmosphere boils into space, forming a shimmering nebula of plasma that glows in X-rays, a telltale funeral shroud. But the pulsar isn't just destroying its partner, it's recycling it. Some of that stolen gas spirals onto the pulsar's surface, fueling its spin like cosmic coal thrown into a furnace. The rest is flung into the void, forming those eerie, elongated legs visible in radio telescopes. What makes the Black Widow especially chilling is its inevitability. The pulsar's gravity ensures the companion star can't escape, locking them both in a death spiral. As the star loses mass, its grip on the pulsar weakens, allowing the predator to drift farther away. But this only prolongs the agony. The slower the pulsar's orbit, the more time it has to blast the star with radiation, ensuring an excruciatingly slow demise. Eventually, the companion will be reduced to a cinder, perhaps even a diamond-like remnant of crystallized carbon, a tombstone for a star that never stood a chance. Astronomers hunt systems like this because they're cosmic gold mines, laboratories for studying gravity, particle physics, and stellar evolution under conditions we could never replicate on Earth. The Black Widow, with its dizzying spin and lethal embrace, forces us to confront the universe's darkest truth. Even the stars aren't safe from the cosmos' appetite for destruction. And somewhere out there, other Black Widows are spinning, waiting, reminding us that the universe doesn't just create life, it devours it. At the heart of the Virgo cluster, a cosmic titan reigns, Messier 87, a galaxy so vast it could swallow our Milky Way whole without a hiccup. But M87's true legacy isn't just its size, it's the evidence of its violent past, etched across its halo like scars from a celestial battlefield. This galaxy didn't grow peacefully, it devoured its neighbors, consuming entire star systems in a feeding frenzy that left behind ghostly shells of stars, concentric ripples of debris floating like echoes of ancient collisions. These stellar remnants aren't just debris, they're trophies, proof of M87's status as the universe's ultimate cannibal. The most striking evidence of this galactic feast lies in its structure. Unlike the neat spiral arms of younger galaxies, M87 is an elliptical behemoth, its stars orbiting in chaotic, random patterns, a telltale sign of multiple mergers. Telescopes have spotted over a dozen of these stellar shells, each one marking a separate act of cosmic consumption. Some shells are so faint they're nearly invisible, detectable only through painstaking analysis of starlight. Others stretch hundreds of thousands of light years, their stars moving in eerie synchrony, like schools of fish trapped in the wake of a long-dead predator. But the real crown jewel of M87, and the engine of its destruction, lurks at its core, a supermassive black hole weighing 6.5 billion suns. This monster, famously captured in humanity's first ever black hole image in 2019, isn't just a passive observer, it's the architect of M87's dominance. As smaller galaxies ventured too close, the black hole's gravity ripped them apart, funneling their stars into the growing halo while their gas spiraled inward, fueling the black hole's insatiable appetite. The image we've all seen, that fiery ring of light encircling darkness, isn't just a scientific milestone. It's a snapshot of the very force that made M87 a galaxy eater. What makes this system so chilling is its inevitability. In dense galaxy clusters like Virgo, mergers aren't just common, they're unavoidable. Smaller galaxies drawn in by gravity stand no chance against giants like M87. Their stars are either absorbed or flung into the void as hypervelocity escapees, while their gas ignites into furious bursts of new star formation, briefly lighting up the devourer before being snuffed out. Even now, M87 isn't done. Astronomers suspect it's already digesting another victim, a smaller galaxy whose final moments are playing out in slow motion across cosmic time. The lesson of M87 is stark. The universe operates on a scale of violence we can barely fathom. Galaxies aren't static islands of stars, they're dynamic, ever-changing entities shaped by collisions and conquest. And at the center of it all, black holes aren't just destroyers, they're the puppeteers of galactic evolution, their gravity weaving the fate of everything around them. As we stare into that iconic black hole image, we're not just seeing a scientific achievement, we're glimpsing the heart of a predator and the terrible beauty of cosmic survival. Hovering in the asteroid belt between Mars and Jupiter, an object named Pizarro behaves like no other. It's a cosmic paradox, blurring the line between asteroid and comet so thoroughly that astronomers still argue over what to call it. Discovered in 1996, this enigmatic body follows a perfectly stable asteroid-like orbit, yet it sprouts a glowing tail of dust and gas like a comet whenever it nears the Sun. It's as if someone stapled a comet's tail to a rock and flung it into the solar system's most crowded neighborhood, leaving scientists to wonder, is this a freak accident or evidence of an entirely new class of celestial object? The first clue to this puzzle lies in Pizarro's orbit, a nearly circular path typical of main belt asteroids, not the elongated, plunging trajectories of comets. Comets usually hail from the frozen edges of the solar system, their icy bodies erupting into tails as they streak toward the Sun. But Pizarro never ventures beyond the asteroid belt, making its comet-like outbursts utterly baffling. One theory suggests it's the shattered remnant of a collision, a once larger asteroid that got smashed apart, exposing volatile ices buried beneath its rocky crust. Whenever sunlight heats these exposed patches, they could vaporize explosively, creating temporary tails. Supporting this idea are telescopic observations showing the tail isn't continuous but flares up sporadically, like a geyser triggered by solar warmth. Yet there's a twist. Some researchers argue Elst Pizarro might be a true main belt comet, a rare breed of icy asteroid that somehow avoided evaporating over billions of years. These objects could be primordial time capsules, preserving ices from the solar system's infancy in regions where no ice should survive. If confirmed, they'd rewrite our understanding of how water and organic compounds were distributed during the planet's formation. Others propose an even wilder scenario. Elst Pizarro might be a captured interstellar interloper, a rogue iceberg flung into the asteroid belt during some ancient cosmic shuffle. Its strange behavior could be the signature of chemistry never meant for our solar system. What makes this hybrid so thrilling isn't just its identity crisis, it's the questions it forces us to confront. Could there be thousands of these chimeras hiding in plain sight, their icy hearts dormant until a random sunbeam wakes them? Are we watching the slow death of an asteroid or the secret life of a comet? Every time Elst Pizarro's tail flickers to life, it taunts us with the same humbling truth. The solar system's taxonomy isn't as neat as our textbooks pretend. Out there in the rubble between worlds, the universe is still inventing new ways to surprise us. Hanging in the void like a colossal cosmic bullseye, Hoag's object is a galaxy so perfectly ringed, it looks like it was sketched by the universe's own compass. Discovered in 1950 by astronomer Art Hoag, this celestial oddity defies all expectations. A shimmering blue circle of newborn stars surrounding a golden core so faint, it nearly vanishes from view, a structure so precise, it seems impossible that chaos could have crafted it. Most galaxies fall into familiar categories: spirals, ellipticals, or messy irregulars, but Hoag's object stands alone. A galactic enigma that spent decades taunting astronomers with its eerie symmetry. The mystery begins with the ring itself. Unlike the messy debris of collisional ring galaxies, where a smash-up between two galaxies flings stars outward in a temporary ripple, Hoag's ring is pristine, almost delicate. Its azure hue betrays a population of young, hot stars, suggesting ongoing star formation, yet there's no visible trigger, no neighboring galaxy to account for the sudden burst of stellar births. Stranger still, the ring orbits at a near-perfect distance from the center, maintaining its shape with gravitational elegance. One leading theory points to a long-ago galactic merger, where a smaller galaxy plunged through Hoag's core like a stone through water, sending shockwaves of gas rippling outward until they condensed into this radiant hoop. But simulations struggle to recreate the ring's flawless proportions, leaving scientists skeptical. Then there's the core's own peculiarities. Most ring galaxies have bright, active centers, but Hoag's heart is eerily subdued, a diffuse ball of older, redder stars with none of the supermassive black hole fireworks seen in galaxies like Andromeda or the Milky Way. Some researchers argue this hints at a rare phenomenon called resonance-driven instability, where natural oscillations in the galaxy's disk amplify over time, pushing gas outward into a ring while starving the core. It's as if the galaxy played a gravitational tune so perfect, it sang itself into this strange, symmetrical form. The plot thickens when you peer even closer. Nestled between the ring and the core lies a gap, a dark, starless moat separating the two structures. This void isn't just empty, it's too empty, as if some unseen force forbade stars from forming there. One provocative idea suggests that the core and ring might actually be two distinct galaxies, one nestled inside the other through some cosmic coincidence, though no known process could explain such a perfect alignment. Others speculate that Hoag's object could be a snapshot of galactic evolution so rare, we've stumbled upon the universe's equivalent of a living fossil. What makes this celestial bullseye so mesmerizing isn't just its beauty, it's the way it upends our assumptions. Galaxies aren't supposed to look this pristine, this engineered. Hoag's object forces us to confront how little we truly grasp about the delicate dance of gravity, gas, and time. And as we stare at this perfect ring adrift in the dark, one question lingers. Is it a masterpiece of chaos or a signpost to laws of physics we've yet to uncover? Right now, an invisible storm is barreling toward Earth at 500,000 miles per hour, a hurricane not of wind or rain, but of dark matter. Scientists call it the S1 stream, a vast river of these elusive particles left behind by a dwarf galaxy torn apart by the Milky Way's gravity billions of years ago. Unlike ordinary matter, dark matter doesn't emit, absorb, or reflect light, making it impossible to see. But its gravitational pull is undeniable, shaping galaxies and bending the fabric of space itself. And this cosmic tempest might finally give us a chance to catch it in the act. What makes this dark matter hurricane so extraordinary is its trajectory. The S1 stream is sweeping directly through our solar system, meaning Earth is sitting in the path of a particle bombardment we've never experienced before. If dark matter interacts with ordinary matter even slightly beyond just gravity, this could be our best shot at detecting it. Experiments like Xeno-NNT and LUX Zeppelin, buried deep underground to shield them from cosmic noise, are on high alert, their ultra-sensitive detectors fine-tuned to catch the faintest whisper of a dark matter collision. Imagine trillions of these invisible particles streaming through your body every second, leaving no trace unless one happens to bump into an atom in a detector's liquid xenon tank, creating a flash of light or a ripple of charge. That's the hope, a fleeting signal buried in terabytes of data, a needle in a cosmic haystack. The S1 stream isn't just a scientific curiosity, it's a natural laboratory. Most dark matter searchers assume these particles are moving at a steady, predictable pace. But this hurricane introduces chaos, with particles racing at wildly different velocities, some even traveling backward relative to the stream. If detectors can pick up these outliers, it might reveal properties of dark matter we've never considered, like how it clusters or interacts with itself. Some theories suggest dark matter could be clumpy, forming microscopic structures that would leave distinct fingerprints in the data. Others speculate the stream might contain a mix of particle types, each behaving differently as they slam into our detectors. Yet the stakes are higher than just confirming dark matter's existence. If the hurricane passes without a single detection, it could force physicists back to the drawing board. Maybe dark matter doesn't interact with ordinary matter at all beyond gravity, or perhaps it's something even stranger, like primordial black holes or particles from extra dimensions. The S1 stream is a gamble, a cosmic roll of the dice that could either crack the universe's biggest secret or deepen the mystery. One thing's certain, we're living through a pivotal moment in the hunt for the invisible. Whether this dark matter hurricane delivers answers or just more questions, it's a reminder that the universe is always in motion, always surprising us. And as those particles flood through Earth, unseen and unfelt, they carry with them the tantalizing possibility that we're on the verge of something revolutionary, a glimpse into the hidden machinery of reality itself. Few images have captured the cosmic imagination like Hubble's Pillars of Creation, those towering columns of gas and dust in the Eagle Nebula, stretching 7 light-years high like a cathedral of star birth. For decades, this iconic snapshot symbolized the universe's creative force, its finger-like tendrils cradling infant stars in their dusty grasp. But when the James Webb Space Telescope turned its infrared gaze on this celestial landmark, it revealed something Hubble couldn't see, a hidden dance of creation and destruction, where new stars flicker to life even as shockwaves prepare to obliterate their nurseries. JWST infrared vision cuts through the pillars, obscuring dust like an X-ray, exposing hundreds of previously invisible protostars glowing crimson orbs nestled within the gas. Some are mere thousands of years old, so young they're still swaddled in accretion disks, voraciously feeding on surrounding material. Others have already begun carving out cavities with their stellar winds, blowing bubble-like voids into the pillar's structure. What Hubble showed as serene and timeless, JWST reveals as a battlefield where gravity and radiation wage war over these stellar cradles, the most stunning detail. Delicate, thread-like filaments of molecular hydrogen, the raw material for star formation, woven through the pillars like cosmic embroidery, betraying regions where gravity is on the verge of collapsing gas into yet more stars. Yet lurking behind this spectacle is a sobering truth. These pillars are already doomed. Infrared data uncovers faint shockwaves rippling through the nebula, remnants of supernova from nearby massive stars that died long ago. These pressure fronts are racing toward the pillars at millions of miles per hour, and when they strike likely within the next 100,000 years, they'll shred the delicate structures like tissue paper in a hurricane. Ironically, the same stellar winds forging new stars within the pillars are also weakening their foundations, eroding them from within. JWST View captures this paradox in heartbreaking detail, a snapshot of creation in progress framed by its impending annihilation. What makes these observations so profound isn't just the scientific payoff, it's the philosophical whiplash. The pillars aren't a static monument but a fleeting moment in cosmic time, a testament to the universe's relentless cycle of renewal and destruction. Hubble gave us poetry, JWST hands us the full tragicomedy, and as we marvel at these towering structures, we're left with a humbling thought. Their beauty lies not in permanence, but in their transience, a reminder that even the grandest celestial wonders are just brushstrokes in an ever-changing mural. In October 2017, astronomers spotted an object racing through our solar system unlike anything they'd ever seen, a dark, reddish visitor streaking past the Sun at nearly 200,000 miles per hour, on a trajectory so extreme it could only have come from interstellar space. They named it Oumuamua, Hawaiian for scout or messenger from afar, and for a fleeting moment humanity had its first confirmed interstellar tourist. But what began as a thrilling discovery soon spiraled into one of the most heated debates in modern astronomy, all because of two bizarre traits: Oumuamua's peculiar acceleration and its impossible shape. First, there was the way it moved. As Oumuamua slingshotted around the Sun, telescopes recorded something utterly unexpected. It sped up slightly, as if nudged by an unseen force. Comets often accelerate like this when their ices vaporize in sunlight, forming glowing tails. But Oumuamua had no tail, no visible outgassing, no coma of gas and dust. It was utterly dark and seemingly inert. This left scientists scrambling. If it wasn't a comet, what could be pushing it? Some proposed exotic explanations, like the sublimation of hidden hydrogen ice, a theory suggesting Oumuamua was a cosmic iceberg, its surface slowly boiling away in sunlight, releasing enough invisible hydrogen gas to account for the kick. Others pointed to solar radiation pressure, but calculations showed the object would need to be impossibly thin, like a sheet of paper, for light alone to propel it. Then there was its shape. Observations suggested Oumuamua was highly elongated, at least 5 to 10 times longer than it was wide, a cigar-shaped anomaly unlike any known asteroid or comet in our solar system. Natural sculpting processes tend to create rounder objects, not ultra-thin needles. Even stranger, its brightness fluctuated wildly as it tumbled, implying an irregular, jagged surface reflecting sunlight unevenly. The more researchers studied it, the less it resembled anything we'd catalogued before. That's when the controversy erupted. Harvard astrophysicist Avi Loeb famously floated the idea that Oumuamua might be artificial, a light sail from an advanced civilization, its flat geometry and acceleration perfectly matching theoretical designs for interstellar probes. The scientific community pushed back hard, arguing extraordinary claims require extraordinary evidence, and no such evidence existed. but the debate exposed a deeper truth. Oumuamua didn't fit neatly into any known category. It was either a freak natural object revealing a new class of interstellar bodies or something even more paradigm-shifting. The mystery only deepened when Oumuamua vanished from telescope view, leaving behind more questions than answers. Had we witnessed a hydrogen iceberg, a fragment of a shredded planet, or however unlikely, a relic of alien engineering, the frustrating reality is we may never know. But Oumuamua's fleeting visit did something profound. It forced us to confront how little we understand about what lurks between the stars. If objects like this drift through the galaxy unseen, how many others have slipped past unnoticed, and what might the next one reveal about the universe's hidden diversity? For now, Oumuamua remains a cosmic Rorschach test, an interstellar ink blot inviting us to project our theories onto its enigmatic shape, while the truth sails forever out of reach. From stars that vanish without a trace to galaxies spinning like cosmic jewels, we've journeyed through 30 of the universe's most baffling wonders, each one a humbling reminder of how little we truly know. These aren't just oddities, they're cosmic puzzles shredding the edges of our understanding, forcing us to rewrite the rules of physics and rethink the very fabric of reality. Whether it's rogue black holes hurtling through space, invisible hurricanes of dark matter, or interstellar visitors like Oumuamua defying explanation, the universe keeps whispering one undeniable truth: we've only just begun to scratch the surface. Think about it, every time we build a bigger telescope or launch a more sensitive probe, the cosmos responds by revealing something even stranger, something we never saw coming. The Boots void's impossible emptiness, Tabby's star's erratic flickering, the Fermi bubble's gamma-ray fury, these aren't glitches in the data. They're glaring signs that the universe operates on a scale of complexity and creativity we're still struggling to grasp. And that's what makes this journey so exhilarating. For every mystery we solve, a dozen more emerge, each more mind-bending than the last. So here's the real question: which of these cosmic enigmas left you staring at the screen in disbelief? Was it the haunting perfection of Hoag's object, a galaxy too symmetrical to exist, or the spine-tingling notion of dark flow, dragging entire galaxy clusters toward something beyond our vision? Maybe it was the chilling reality of the Black Widow pulsar, a celestial predator slowly devouring its companion star. Whatever stuck with you, one thing's certain: the universe is far weirder, wilder, and more wonderful than any fiction. This isn't the end of the story, it's an invitation to stay curious, to keep questioning, and to remember that every night when you look up at the stars, you're gazing into a vast, uncharted ocean of mysteries waiting to be uncovered. If today's discoveries leave you hungry for more cosmic adventures, hit that subscribe button, because the universe isn't done surprising us, and neither are we. The next revelation could be just one video away. Until then, keep wondering, keep exploring, and never stop looking up. The cosmos has so much more to show us.